All right. Now, 13.3, okay? Trig functions of angles. Now we're going to kind of put the two things together. We're going to take looking at these angles and figuring out how to draw them, and we're going to combine it with finding our trig identities. We're going to put them all together. Now, do you need to absolutely know all of this business?
Yes.
No. Because what's going to happen is we're going to put number values with all of this, and as long as you know your basic trig identities, that like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, you're going to be able to just use that on these. Is it a nice reference? Sure. But is it an absolute necessity? Not necessarily. So here's how this is going to work. Because it says the terminal side of our angle in standard position contains each point. Find the exact values. Now, if you're not going to know these off the top of your head, it would help to possibly draw a picture. So I'm going to draw pictures with these, and then some of you may decide you would rather memorize this instead. So if I was to do just a quick sketch here, and I'm not looking to be real accurate, I'm just trying to get an idea. The point 512, okay, if I were to number my quadrants, because this is how quadrants get numbered when we're graphing, which quadrant would 512 fall into? The first one, because I'd go right 5 and up 12. And again, I'm just putting a basic point in there right now. If I were to draw a triangle, you're like, well, how are you going to draw a triangle? Well, I'm going to start and always make my hypotenuse of sorts coming from my origin, and then pull this straight down. You're like, okay, I can see how you could do that. Well, what does that mean still? Well, when I have a point, my x value would be how far I go on my x-intercept. My y value would be how far I go on my y-axis. And then, of course, whenever we're doing anything with trig functions, we need to know what the hypotenuse is. How would I figure that out?
X squared plus y squared and the square root of both.
Right. Basically, I'm going to square my x and my y here. And we'll call this r, because that's what they like to call it up here. So r squared is going to be 5 squared plus 12 squared. Yep. So if I add 5 squared and 12 squared, I get 169. Take the square root, and my r value, or my hypotenuse, is 13. And now it's just like what we were doing on the first day of right triangle trig. I have all of my sides. You're like, yeah, but what angle am I working from? That would be a good question if you hadn't thought of it. We're always going to be using the angle that's working along the x-axis. Okay, so my theta in this case is going to set up right here. So with knowing that, what's my fraction going to be for my sine?
1213.
Okay, because it's going to be opposite over hypotenuse.
Oh, I just did the key thing up there.
So, and you can. You absolutely could use this. If some of you are looking and saying, oh, okay, so r here now
13.
is 13, so it's y over r. It's 12 over 13. So the formulas up here work, but it also works if you look at the picture and kind of mentally work your way through it. What about cosine? 5 over 13.
I thought they wanted the number.
And tangent? Okay, because it's opposite over adjacent. Because once I know the first three, life becomes just grand. Because remember, the inverse just means literally the inverse. You flip it. So cotangent's 5 over 12. Secant's 13 over 5. And cosecant would be 13 over 12. I have my 6 trig functions, and that's the exact value. Because if I go to a decimal, I'm rounding somewhere, and, well, that's just not good. Okay? So now, on number 2, I'd have the same concept working. Now again, you may choose, we'll do one each way, and then you can kind of give me an idea of which way you want to look at this. Again, to find my r, I'm just adding the squares of my x and y and taking the square root. So my r for this one, 9 plus 16 is 25, and the square root of 25 is 5. So I could just use those three values to find all of my functions. Or I could draw a picture. It depends. So here, if I look at this and I know that my sine is y over r, okay, it's 4 over 5. Cosine is x over r, 3 over 5. And tangent is y over x. So there are some benefits to knowing these, because I don't have to draw a picture then. Because once I have these three, again, I can just take their inverses to find my alternate value. However, there's always going to be some benefit.
Do we have to pull out an I?
No, there will be no i's involved with any of these. Because now if you look at this one, and again, I'll go back and I'll kind of do a picture again here to let you see how this works. So if I were to draw my axes and approximate the point that's there, 8, negative 15, okay, I'd be down here in the fourth quadrant somewhere.
But it's still in 15.
What? Nope. When I drew my triangle, and this is the part that's going to be kind of funky to some of you, my x value is 8, because I went right 8. And for the first time ever, you get to use the side of a triangle as a negative. The y value is going to be negative 15. And the reason I use the negative here is because as you work through quadrants when you're using trig functions, the signs change on them. And that's something that you deal a little bit more with when you get into the actual trig. We're going to keep life a little bit simpler and just kind of visualize this. So when I go to find my hypotenuse, or my r value, okay, so my r squared would be 8 squared plus negative 15 squared. Now again, when I square a negative, it's going to come out positive anyway. So when I add these together, it would be 64 plus 225 would be 289. And when I take that square root, my r value is 17. So if you're comfortable using the three forms up above, with sine being y over r, cosine being x over r, tangent being y over x, that's fine. But otherwise, you can finish off your picture. Remember that the angle you're working with is always the one that's attached to my x-axis. That will never change. And then start doing your trig functions from there. So again, if I've got the picture, opposite over hypotenuse, negative 15 over 17. Adjacent over hypotenuse, 8 over 17. And tangent is opposite over adjacent, negative 15 over 8. And again, just take the inverse for your other trig functions. You're like, all right, Hardy, we know that everything will not end up being quite this straightforward. It never is. So where's the catch? Well, let me show you the catch. The catch is number 6. The catch is, not every time will you get a nice round number for everything. It just won't happen. So, if we head up a little bit and head towards number 6, let's figure out a couple of things. Okay, let's figure out our r. I know, but 4 is even not nicer. 6 is semi not nice. So we will go semi not nice. Add my squares. You're like, uh-oh, 5's not a perfect square. This doesn't clean up nice. Nope, we're going to have a radical. So, here's what we've got working. Now again, you can go picture or with the forms at the top. Some of you may start getting tired of drawing triangles all the time and decide that you're going to decide to know your form. But here's x, here's y, and now I know what my r is. Here's my theta. So I start to work through these. So I get to sine. Now what's sine going to be?
2 root 5, you can't have it.
Okay, 2 over the square root of 5. Uh-oh. Cannot have a radical in the denominator.
2 root 5 over 5.
Okay. Right. Remember, these are the ones, and we'll take a closer look at this first one, then I'll be like, oh yeah. If you multiply by the radical, zoom in a little here, because I'm sure some of you towards the back are going, whew. I get 2 square root of 5, and my radicals just cancel, because 5 times 5 is 25, and that's square root would be 5. I can't reduce this anymore, so that's going to be my value. Now, before you go doing extra work for your inverse, you don't have to, because if it's 2 square root of 5 over the square root of 5, and I flip it, there's no radical in the denominator to begin with. So again, don't go into overwork mode. They don't look like they're inverses, but they are. Cosine's going to get me in the same issue. 1 over the square root of 5. And right, you'll start to look at these and go, okay, so square root of 5, square root of 5. So it's 1 square root of 5 over 5. Because again, the square root, when I multiply, it's just going to cancel down here, and I just tack it onto the top, basically. I can't reduce that. This is under a radical. This isn't. I'm done. Same thing here. Square root of 5 over 1, or if you just wrote square root of 5. Whoops. Let's get in the screen. And we love tangent. Opposite over adjacent. 2 over 1, or 2. Cotangent, flip it. So if you run into one where you get a radical for your r, you're going to have a little bit of extra work to play with. But don't let it be something that freaks you out. Because it's not an issue, it's not an issue, it's not an issue. Now, let's do this. I'm not going to go overboard today. I got one last thing. We're going to kind of keep inching our way ahead on this. So for a moment, flip over. When we get to the back, okay, we get back here to what's called a reference angle. And when we play with reference angles, we have to have an idea of what quadrant, and that's why we talked about it a minute ago, my angle ends up being in. And there's one adjustment we're going to make up here at the top. My fourth quadrant got cut off. So we've got to get that updated, but the rest of these will end up being okay. So,
Oh, that's just zeros. Oh, not degree.
yep, just my little degree things. Yep. So when it says sketch each angle, then find its reference angle. Because what we'll be able to do soon is, without even having a calculator, we're going to be able to figure out what these measurements are for my trig functions. Because we're just going to use the special triangles that we dealt with before. So here's how this works. Okay, I need a 135-degree angle in this first one. Well, I start looking and I'm like, okay, I'm going to be between 90 and 180. Once I get to the 90, because I know I'm going that far, how much more do I need? To get from 90 to 135. 45. So, get lined up. I go find my 45. Get that out of the way. Get this drawn in. And mark that through. You're like, okay. So when I'm looking for its reference angle, okay, what I'm attempting to do is to actually say, now, to get from here to the x-axis, how much further do I have to go? Okay? So reference angle, how much further to the x-axis do I need to be going? Now visually this time, I'd hope this would be fairly simple to see. Because if I'm 45 degrees going in from 90 to here, probably means I need another 45 here. But do I want to actually have to sketch it every time? No. That's what this little chart kind of helps us to do. For me to get from here to here is 45 degrees. That would be my reference angle. But I also, knowing that my terminal side is in quadrant 2, I can just do 180 minus the angle. Okay, there's shortcuts for a lot of things here where I don't have to keep drawing pictures, but I've got to work with it enough to be able to understand what I'm doing. But that's all I'm doing with this one. So for instance, if I'm doing that same thing with number 8, 200 degrees, which quadrant is that going to end up in? The third, because it's going to come past here. Now, if I just get to where I'm used to the formula is take my degree measure minus 180. So I would do 200 minus 180. I get 20 degrees and I go about my business. But let's see where that comes from. So if I was going to draw this one, I'd go 90, 180, and I'd get here, and I'd say, okay, I need 20 more degrees to get where I'm going. And you're like, hey, that's the answer. Now you're starting to catch on at that point. Get my 20 here. And draw my line. I did the 180 there, but my reference angle is right here. How far is it away from the x-axis? Well, it's 20 degrees. We just said that when we drew it. So that's what you're actually finding on these. You're like, oh crap, here come the radians. Don't let the radians freak you out. There's no need. Let's turn it into degrees. 180 over pi. Yep. So I have a 300-degree angle. Okay. What quadrant is that going to end up in? The fourth, because I've got 0, 90, 180, nope, 270. It's going to be over here somewhere. So I look up top, and if I'm in quadrant 4, it's 360 minus my measure. So it would be 360 minus 300, which would be 60 degrees, but
in radian mode.
If you start in radians, okay, your answer needs to end in radians. So even though I figured out that this is 60 degrees, I need to make my conversion. So I need to do pi over 180 and then multiply across. So I'd have 60 pi over 180, but I just reduced the 60 over 180 part and get my answer. So if I was doing this, I'd go 90, 180, 270. Get that last 30 degrees right here. And it's that part. Okay. Now you're like, well, wait a minute. It's only 30 degrees to here. Why is my answer 60? Remember, how far is it to the x-axis? So it's not here to the y. Okay. This is the portion that I'm looking for. Okay, now, before you go into complete and utter panic, hear me out. Your number one goal, okay, I'm even going to put it on here. This is going to be great. Your number one task, we're going to put things in order here. Finish page 780 to the best of your ability. If we need to do some questions tomorrow, we can. But for the most part, that needs to be done tomorrow. Part 2. We're going to start page 788. And let me list these off. Because I'm already going to start making adjustments and we haven't even gotten anywhere yet. No, because there are some ways when we get, you're not to this part yet. When we get to that part, there are people that start shortcutting this, and it's going to screw you over. So that's why I'm going to kind of force the issue on that. For right now, okay, that's the part you can handle right now. 7 problems.
Okay, on top of 18.
There's 18 problems if you incorrectly did not do any homework yesterday.
Okay, I did 1, 2, 3, 4, 5, 6, 7 again.
Again,
19
incorrectly did homework yesterday because you were capable of doing the first like 12 of those. As far as tomorrow being a worksheet with this, scratch that idea. There is a possibility that we end up quizzing on Monday because I want to make sure we get it, but I'm not going to start losing days with things. So that's what the goal is right now. Tomorrow, once we finish the rest of these notes, you will have more time tomorrow to be able to finish some things up. And that's what we're going to do.